Imagine stepping onto a train in London and arriving in Paris just over 2 hours later. No airports, no ferries, just a smooth, uninterrupted ride through one of the world's most remarkable engineering achievements. This is the magic of the Channel Tunnel, an undersea railway connecting Britain and France. Yet, behind its modern convenience lies an incredible story of ambition, groundbreaking technology, and human sacrifice. How did engineers create a 50-kilometer tunnel beneath the English Channel that many believed was impossible? Let's embark on a journey to uncover the fascinating history of the Channel Tunnel, a modern wonder of the world. The Channel Tunnel, often called the Chunnel, is an engineering marvel linking the United Kingdom and France beneath the English Channel. Completed in 1994 after 6 years of intense construction, the tunnel stretches 50 kilometers in length, with 38 kilometers submerged under the seabed. This direct link between two nations revolutionized travel and trade across Europe, turning what was once a 6-hour ferry journey into a smooth 2-hour and 15-minute trip by high-speed train. Today, over 20 million passengers use the tunnel each year, making it a cornerstone of European infrastructure. However, the story behind the Channel Tunnel is one of persistent ambition and struggle. For centuries, the English Channel served as both a natural barrier and a political symbol. While it protected Britain from European conflicts, it also hindered trade, travel, and cultural exchange. Proposals to link the two nations date back over 200 years, but it wasn't until the late 20th century that the dream finally became a reality. From early conceptual drawings of undersea passageways to the monumental challenges faced by engineers during construction, the journey to build the Channel Tunnel is as extraordinary as the structure itself. The idea of connecting Britain and France is older than you might imagine. In 1702, French engineer Albert Mathieu Favier proposed a tunnel for horse-drawn carriages. His innovative plan included ventilation chimneys rising above the waves and an artificial island midway across the channel for travelers to rest. While revolutionary for its time, the proposal was ahead of the available technology and failed to gain traction. Throughout the 19th century, as railways transformed transportation, new tunnel designs emerged. By the 1850s, engineers were proposing undersea railways that would rely on primitive tunneling methods. Advances in materials like iron and steel made these ideas more plausible, but political tensions between Britain and France repeatedly stalled progress. Many in Britain saw the channel as a crucial defense against invasion. The notion of a fixed connection between the two nations was met with suspicion and resistance, particularly during times of conflict. Efforts to build a tunnel gained momentum again in the early 20th century. By this time, tunneling technology had improved significantly, and the idea of an undersea railway became more technically feasible. However, 2 world wars and shifting geopolitical priorities meant that serious work on the project was postponed for decades. In the aftermath of World War II, Europe began to rebuild itself, and the notion of cooperation between nations gained importance. The idea of a tunnel beneath the channel resurfaced as part of broader efforts to strengthen economic ties across Europe. By the 1970s, both Britain and France recognized the potential benefits of a fixed link, not only for transportation, but also for fostering trade and unity. In 1974, construction on a channel tunnel project briefly began, with crews on both sides starting excavation. However, the British government abandoned the project a year later due to economic challenges. This false start only fueled skepticism about the feasibility of building such an ambitious structure. It wasn't until the 1980s, under the leadership of French President François Mitterrand and British Prime Minister Margaret Thatcher, that the project regained momentum. In 1986, the two nations signed the Treaty of Canterbury, a landmark agreement that set the stage for the modern Channel Tunnel. Unlike previous attempts, this project would be privately funded, with a consortium called Eurotunnel, formed to oversee construction and operation. The chosen design included two main rail tunnels and a smaller service tunnel, with an estimated cost of $3.5 billion. Despite optimism, the road ahead was fraught with challenges. Construction of the Channel Tunnel officially began in 1988. 11 massive tunnel boring machines, TBMs, were deployed to excavate the rock beneath the seabed. These TBMs, each weighing thousands of tons, were technological marvels designed to cut through rock, remove debris, and line the tunnels with reinforced concrete as they advanced. Crews began digging from both sides of the channel with the aim of meeting in the middle. Precision was critical. Any misalignment would result in catastrophic delays. Engineers chose a route through a stable layer of chalk marl beneath the seabed. This material was easier to excavate than harder rocks and provided natural support for the tunnels. However, conditions on the French and British sides differed significantly. The French side faced numerous fault lines and fissures, allowing water to seep into the tunnels. Engineers had to develop waterproof TBMs and use grout to seal cracks as they worked. On the British side, crews encountered unexpected water infiltration, which required additional reinforcements to prevent flooding. The TBMs advanced at a painstakingly slow pace, averaging just 3.5 meters per hour. Behind the machines, workers installed concrete lining rings to stabilize the tunnels. The operation required meticulous coordination, with surveyors using lasers and satellites to ensure the two sides would meet precisely in the middle. On December 1, 1990, the first major breakthrough occurred. Crews working on the service tunnel, the smaller central passage, finally met beneath the seabed, marking the first physical connection between Britain and France in over 10,000 years. The moment was celebrated worldwide as a symbol of international cooperation and engineering triumph. The image of British and French workers shaking hands through the breakthrough hole became an enduring icon of the project's success. While this milestone was significant, much work remained. The two main tunnels still had to be excavated and outfitted with tracks, ventilation systems, and safety features. The service tunnel, meanwhile, played a vital role in supporting construction and ensuring the safety of workers throughout the project. The final phase of construction involved equipping the tunnels with state-of-the-art systems. Engineers installed over 300,000 shock absorbers to manage vibrations from high-speed trains. Fireproof doors were added to enhance safety, along with cross passageways connecting the main tunnels to provide emergency exits. Advanced ventilation systems regulated airflow, while a specialized cooling system addressed heat generated by the trains. Despite these advancements, the project faced significant delays and cost overruns. By the time the tunnel was completed in 1994, the total cost had soared to over $15 billion, making it the most expensive infrastructure project of its time. Yet, the finished product was nothing short of extraordinary. The Channel Tunnel officially opened on May 6, 1994, with a grand ceremony attended by Queen Elizabeth II and President François Mitterrand. Eurostar trains began carrying passengers between London and Paris, transforming travel across Europe. Freight services followed, enabling seamless trade between Britain and the continent. Today, the Channel Tunnel is celebrated as one of the 7 wonders of the modern world. It handles millions of passengers and tons of freight each year, contributing significantly to the economies of both Britain and France. More than just a transportation route, it symbolizes the power of collaboration and the possibilities of modern engineering. Yet, the tunnel's legacy is not without challenges. Incidents such as a 1996 fire on a freight train raised safety concerns, prompting Eurotunnel to implement stricter protocols. Additionally, debates about the tunnel's financial viability and its role in post-Brexit Europe continue to spark discussion. Despite these issues, The Channel Tunnel remains a vital link between two nations and a testament to human ingenuity. If you enjoyed this journey through the history of the Channel Tunnel, don't forget to like this video and subscribe to our channel for more deep dives into the world's most incredible engineering achievements. What other mega projects would you like us to explore? Let us know in the comments below. And next time you travel beneath the English Channel, take a moment to appreciate the monumental effort that made it all possible.